Hello and welcome to Built Environment Matters, a monthly podcast brought to you by Bryden, an international company of technologists, designers, architects, engineers and analysts working for a better built environment. Bryden believe in design to value, to cut carbon, drive efficiency, save time, make beautiful places and build a better future.
Hello there and welcome to this edition of Built Environment Matters, the Bryden podcast. I'm your host, Jaimie Johnston, Head of Global Systems here at Bryden, and today I'm delighted to be joined by Lincoln Wood from Edged.
Hi, everyone.
Great to have you. Bit of context, Lincoln is a design and construction executive with over 20 years experience delivering lots of projects, complex projects across all sorts of sectors, including commercial high-rise, utility plants, data centers, professional sports stadia, and multifamily residential. He's led teams across all facets of the delivery process, from design, supply chain, construction, and lots of innovation. Currently, and the reason why we met Lincoln, is the Director of Design at Edged, leading the strategy and delivery of data center design, which we're going to talk a lot about today. Before joining Edged, he was Head of Delivery at real estate developer Juno, where he oversaw supply chain and construction of mid-rise prefabricated buildings using mass timber. So sustainability and innovation, I think, the through line of Lincoln's work. While he was at WeWork, he supported over $2 billion of projects across multiple operational roles, and served as Vice President of Construction for the in-house general contracting company. He also worked for Turner, who are a big US general contractor, where he was Director of Innovation and Technology. And prior to all of that, he studied at University of California, Berkeley, with a focus on architecture, city planning, and psychology. So you can probably see why we get on. Studied architecture, lots of innovation, worked across sectors. So Lincoln, thanks for joining us.
Great to be here.
That's quite an interesting CV. It's quite a journey you've been on. I think it's quite interesting that you didn't grow up in data centers, but like us, you've kind of found your way into this space. It's probably just a level set for people who aren't in this space. It'd be good if you could explain what an edge data center is, why that's different to other types of data center, what Edged as a company is specifically interested in, and the kind of context of Endeavor, which is the sort of broader company background.
Absolutely. So to give kind of a broad view, Edged is a data center developer with a global footprint where we're building data centers currently in Europe and all over the United States, and that's growing. And we operate very much like a colo developer as far as that particular space. We take down land, or we take control of the land. We develop the design, we manage the construction, and then we operate that facility with tenants, and those tenants are the people that are our customers. And so that's the business model for a colo developer doing data centers. Where we're a little unique is that we have a company that oversees us, or on top of Edged, which is our mother company called Endeavor. And Endeavor's bigger purpose than just data centers is really trying to solve global climate challenges that we're facing right now with regards to the access to energy to meet the demands of these colo tenants, while not continuing to hurt our planet. And so technology, beyond just building and designing these facilities, is a core requirement to be able to innovate in this space that we're in right now, which we'll obviously talk more about. So when I talk about hard technologies, I mean the engines, the ability to cool these facilities. That takes deep manufacturing expertise, design expertise, mechanical expertise, to know how to address some of these challenges, to be more efficient with our use of water, or our ability to utilize the energy more efficiently to meet these demands. So Endeavor has been set up to support Edged as a data center developer by providing these unique technologies into our platform, while also staying focused on what needs to be developed for the future of these data centers as we keep evolving as a company, but also for the broader landscape of other types of businesses and use cases for those technologies.
Yeah, it's a really interesting example. We've talked about this on the podcast before, this sort of convergence of what used to be different sectors. So energy and data center particularly are starting to converge. So again, for just as a part of a level set, for those who aren't familiar with this space, so the data center typically measured in megawatts, which is the amount of power they consume. It used to be back in the day that was kind of measured in the low tens. It's risen, certainly for hyperscale data centers, some of these big things, into the kind of low hundreds. There's lots of talk now about the future data centers, specifically the AI first ones, which will be measured in gigawatts, so the order of magnitude increase. So a couple of figures that someone sent me earlier today, data centers are projected to consume over 9% of US electricity annually by 2030. So nearly 10% of the power in the country will go into one building type, which is an increase from the previous estimate of 4 or 5. So AI, we'll talk a lot about, has taken everyone a bit by surprise. McKinsey thinks the data center demand will reach 35 gigawatts by 2030. So, gigawatts is the equivalent of a small city in terms of power consumption. So obviously that, as Lincoln says, is putting a huge premium on how do you make these things more efficient and more sustainable. But perhaps going back a step, we think it's interesting in this market. Data centers, probably more than any other, are kind of living the industrialization sort of process. Perhaps you can unpack why data centers particularly lend themselves to industrialized construction, and what are the kind of the factors that are coming together to make that true.
Yeah, I mean, I think you touched a little bit on my career. There's an arc or a narrative that has been a common thread, and that's really trying to reduce the silos, create more efficiency on the value chain from project design or the onset of project all the way through the turnover process to the client. Witnessing that, my first job out of college was a carpenter for high-end residential, and saw some brutal mistakes and wastes of material, on those projects firsthand as I was out in the field. And then quickly came in and did some development work in the Soma region of San Francisco, doing multifamily, working for a developer that was the architect, the developer, and the contractor all in house. And then so kind of cut my teeth on projects, whether I was on the design side, the construction side, or even in the field, and just the blatant, intense inefficiency, whether it's waste of materials or the silos and the steps, the process to deliver that work. It was a big passion of mine that started then, to really kind of figure out how can we solve some of those big opportunities. And so when I worked at Turner, it only gets magnified, some of that waste. But with a company of that size, it offered me an opportunity to explore different innovations, new technologies, things to think about things a little differently. And that was a great launching pad to really a product-focused career path that really turned towards thinking about how can we build and design for more of a product approach. It's not for every project, right? There's going to be projects that are site-specific, that have a particular set of requirements that will be unique for that project. But there's a lot of examples in the world where products have been a successful platform to gain that efficiency, that opportunity to really leverage the repeatability of the design, the repeatability in the supply chain, and ultimately the steps in the field for the contractors and the subcontractors to install more efficiently and have better quality hand over to the client. So that mission, let's call it personal mission, I went to WeWork and did that on a TI kind of platform, tenant improvement, office fit outs, because we were designing and building products there as well. Went over to Juno and did that on a multifamily level for mid-rise and high-rise buildings. And now at Edge, what's interesting is, my time at Turner, I had exposure to a program, a large hyperscale program, working on the innovation side, but had a lot of exposure with that work. And so in my mind, it was always a great place, a great platform to really experiment with some of the ideas around a platform, the ideas around leveraging repeatability in design, and a more detailed coordinated design than most projects you see, given the ability to harness the economies. So finding Edge was a great spot for me to kind of take that journey and apply it back into the data center space. So really from day one at Edge, my role as director of design is really trying to develop our language, our call it our kit of parts, that are agnostic to site, that can address as much of the range of constraints and limitations that a site can provide, that allows us to have a repeatable, call it kit of components that we can manage, condition, and learn from as we deploy them in projects and see the site adaptation that occurs when we do that. So really defining the process to do that, hiring the people to do that, and then going and executing on that in an operational way is kind of where my focus is at Edge at the moment. But with everything we talked about earlier with regards to the space and just the unique moment in time that the data center space is facing and in a way ramping up for, amongst other technologies and everything that's involved with what we talked about, it's a really exciting time to be in the space. So yeah, I'll stop there. But I think the point being that data centers are standard. It can be very, very well suited towards standardization. I guess that's the other piece that I wanted to mention, is that through the journey of building a lot of different projects, you can find those patterns in the design that make sense. And for a data center, it's an industrial style building. It's less aesthetically driven. From an architectural standpoint, there are still the requirements for egress and life and safety and all the things that must be considered, given that there are people that occupy these spaces and work within them. But it's a building filled with really, really complicated and unique technologies. It's more of a machine than a home or a place where you're considering people as much as you would on the conditions and the execution of that space from an energy standpoint, to process the data. So it's a great platform for that, and I've been successfully working on this and finding the right partners who are well suited to do it. And obviously, the company at Edge is very interested in doing this because of our growth and our scale up, which is so aggressive so we need a plan that can help us to move fast and move into markets quickly.
Yeah, you made a comment that I noted down, actually, that you said that because the sector was developed to deliver kind of one-off projects, lighthouse projects, like that's how the skills have developed, and so everyone has got good at doing one-off things and adapting, on the fly, creating these new teams. And so that's not surprising. That's how the industry is developed as a response to the way we used to build things. This is a different thing. You use the term engineering first, which I think kind of, that's that comment about it's a machine. It's a piece of industrial design.
Yeah. I can talk a little bit.
Set.
I can fill that in a little bit, Jaimie, because I think it's important to say again, like the time when a lot of these data centers started moving into cloud and this large scale up even occurred. I remember when I was at Turner, our data center portfolio grew substantially right around, I don't know, the 2012 timeframe, I think, was when it really started to boom. And that was a moment. And the players that can develop these large hyperscale data centers are the contractors, the design firms that are been doing complex work, right? Those are the people that are highly qualified, that can bond those projects, that can support it from a labor perspective, or have the foothold in that market for the subcontractors to mobilize teams to do the work. And so I think some folks had done them before, but a lot of them were learning themselves. But that was one part of their portfolio. They're building a lot of other projects at the same time, and those people that in those organizations have been trained on traditional deliveries methods like design bid build or design assist, and those are all good methods to deliver a project. But I would say the traditional team makeup, org chart, let's call it, always had the architect as prime, sitting as job captain or manager of the team. And that's not always to say that that's not the case in the data center world either. But my experience within Edged and what we're doing with regards to the component system is I'm working more with folks that are on the engineering side that have more industrial project experience that overlap with oil and gas or heavy civil projects. Folks that do windmills, for instance, and the folks that are doing that work within these firms are very let's just say trained and are comfortable thinking about a standards environment, thinking about detailed information at the design stage, which is oftentimes less or not as high of an investment within the traditional conventional projects, because you're not going to design it ever again. So you push a lot of that work into the construction phase. Whereas when you're doing standards, you design things to a high level of detail and fidelity early, because you want those details to work in the field, for one, but you also know that you're going to reuse those details. That's a mind shift, and you have to have full commitment in that journey as an organization on the client side, but you also need partners that can deliver on that. So oftentimes as a developer, you RFQ and you go meet these teams, whether contractors, design firms, and I go to great lengths to really get to know these firms, to know what's their DNA as an organization. Have they really made the choice? Do they have the talent in-house to go and execute on this? Have they had the reps at doing it? Have they learned? Because I need the learnings from each company who's done this as much as my own to know we're in the best position to be successful. So yeah, you always can say it's the team that's on your project that matters most. The company, obviously, you start there, but there's unique. I think there's definitely a strategy in selecting your partners, and then you can also say different parts of the world have different strengths around that background, that expertise. So we found that, for instance, Bryden Wood, you guys had a unique skill set where you weren't, based in the United States. So you can't just look within the world that you know. You sometimes have to explore a bit more, and because this isn't all, I wouldn't say it's cutting edge, but it's not something that everyone does, and because of that, there isn't a tremendous amount of experience, I would say, in the world at doing this.
Yeah, that's a nice segue into the next thing I was going to pick up on. So our experience, we've seen, we used to go and talk to US clients, and the way we do data centers certainly in Europe, because sites are constrained, there's not enough land, things tend to be multi-story. So a lot of those skills were perceived to be, or experience was perceived to be, less relevant in the US, because again, we've got these massive sites, we build single story, we don't have the same constraints. That seems to be less true now, certainly as the kind of intensity of some of these things is ramping up, certainly through AI and things. And like as I was looking at edge data centers, you're getting closer to city centers, you're using more urban sites. And so suddenly a load of things that we were, the difference in the different types of data centers is starting to blur, and the difference in the experience of, very constrained, compact buildings in Europe versus large sites in the US. Though all of those things are sort of blurring. Is that a fair sort of statement that everyone's facing challenges and they're all starting to converge on the same sort of constraints and same sort of problems now?
Yeah, I mean, I think what you're speaking to is, well, one, in that we have a European group that's doing projects, right, and they have to often deal with the fact that there is less land available to just develop a site, and oftentimes they have to deal with an existing building which offers all levels of complexity that aren't in a ground up project, which are constraints, right? Which just means that kit of parts approach has to be that much more flexible to adapt to those types of constraints. In the U.S., we're not as constrained to those space limitations as we are in Europe. So we often look for ground up sites. That being said, depending on the type of data center, with the edge being kind of a low latency requirements for processing from some of our clients, which we refer to as like a edge data center. That's a whole new space where, the type of data center, the size of the data center, the ability to interface within neighborhoods, communities, if you're considering things like noise, just security, a lot of those factors in the U.S. are becoming much more of a thing as we build closer to these urban markets. But yeah, a lot of the sites have a lot of land and a lot of space to operate within, so you're not worrying about. There are multi-story data centers, but nothing too aggressive, and the site logistics of things that would always enter into an urban infill site with all the complex scenarios to consider from safety, et cetera, are they're still there safety-wise, but not because of that tight logistics challenges of shipping deliveries and cranes moving materials over cars and other buildings, et cetera. So.
Yeah, and then the two big driving forces which are transforming everyone's experience is just the focus on sustainability and linked to that the rise of AI. So perhaps let's talk about AI a bit. You made a comment that I thought was really interesting. Recently, you were saying the fact that you're not a data center veteran doesn't particularly matter because everyone's on a learning curve. AI is transforming everything. All of the metrics are different. The whole design approach. So maybe you can unpack that and talk about that a little bit.
There are parts that we can maybe agree that people are all learning for the first time, which is a cool thing. I will not say that I am not disadvantaged by not being a veteran. The fact that we have people on the team with decades of experience is incredible to have on my team. I'll be the first one to admit there are certain things where there's gaps because I haven't been doing data centers my whole career. But there is this unique moment on the AI design, things focusing on things like liquid cooling, many points of view, many business models are being created around this, from the client side to the service provider side. People are very busy trying to support this growth. And what that does is it's a knock-on effect on the systems, the equipment to support that AI, that density, and that increased IT power that's required on that footprint that otherwise wouldn't be. So, it's pushing the needle. It's pushing all of us to innovate pretty hard. And so, I'm in conversations all the time, whether or not it's a new client that's asking for 100 plus kW per rack, which is a big leap in density since the days of not so long ago, where we're in the tens. 10 kW per rack is not a unusual number, and still isn't in some use cases. But the increase in that demand per rack has applied pressure on our mechanical cooling systems, and just the design to do that. And so everyone is designing, but it's really going to take a lot of built projects with record data, and to get much better at this over time, at the scale of hyperscale, right? Which is the bigger deployments. So it's an exciting time frame. I think people are energized because the people I work with at Edged are innovators, and we're all mission driven here. So solving some of these problems, and then also having the drive to solve them with a sustainability mindset is it's inspiring. And I'm seeing the learning take place between everyone, all the engineers in-house and out of house, around how we can do things and do them better.
Yeah, can you talk through some of the technologies? Because that point about yeah, it's a phenomenal time where people are having to learn how to do this stuff at the same time they're physically deploying the project. And it's not like you get, a long duration to try a thing, see what you learned from it, deploy it on the next one, iterate. It's not happening like that. It's happening almost in real time. The old analogy of like trying to change the wheel on the car while it's driving down the motorway. But some of the technology, particularly around cooling, the sort of liquid versus air, waterless data centers, all of those sorts of things, people are trying to experiment, but also not leave themselves exposed to massive risk that they deploy technology too quickly. Can you talk around some of the things that are happening in that sort of experimental space?
I think this is an interesting tension, because with density, assuming it's the same amount of power you're providing to that facility, with that density, you could decrease the footprint of your form factor, of your data hall, let's call it, pretty substantially. It's actually pretty shocking how small it could get, which can open up opportunities on the land side, right? So we could look at other deals that maybe weren't possible previously, where we wouldn't have had the acreage to support that data center. That being said, I think that tension or that overlap around, future proofing or having a risk mitigation plan in the mind of that client or in the mind of us as the developer is having a backup plan, or have the flexibility to go back and forth from a liquid solution that would support that AI high density rack, but also have the ability to go and support those racks with an air cooled solution, which is really what's going on right now. That's the conventional approach, is an air-based cooling solution. So oftentimes we're thinking about the design as being able to flex between both, and we support that larger data hall for now, just to have that ability to not, let's call it, box ourselves into a high density play when we may still need to have some air in the building, or some air supported cooling for a lower rack density. I'll say that we're seeing still even the lower rack densities requests coming in from clients are still higher than they were several years ago, that are just kind of the standard typical cloud kW per rack densities. So even the low has gone up pretty substantially. So, but that's still being able to be supported by air.
Yeah, and the other sort of looming thing is so cooling is one thing. Obviously, power is the other sort of massive problem. So I know industry wide, from the figures I said earlier, the amount of power that's going to be needed for these things, it's not like the grid has endless spare capacity at the moment. So the other sort of looming problem is this sort of power availability, energy security, and those sorts of things. But yeah, there's all sorts of interesting things happening in this space at the moment where there's examples where energy companies are partnering with data centers and other providers to start looking at creation of power. Microsoft put a thing out in the public domain recently about looking at SMR. So the idea that data center companies might have to become their own utilities providers, or start to, again, that idea of blending different sectors. I think that's really interesting, this idea that data centers have become not just recipients of power, but potentially participants in the grid, more active parts of the kind of energy network strategy. Perhaps you can talk about that a bit, because obviously Endeavour has got a strong interest in this aspect.
Yeah, and that goes back to building technologies that play within the ecosystem, which the data center is one piece, right? It's actually an end user, right? And the way I understand it is that our grid, that there's more than enough power per se. It's really in the distribution to the data centers, the transmission lines that are where the blockage is between being able to get power out to these sites at the rates and at the demand that's increasing. So you see the utility companies, backed up with requests, and it's a major, call it constraint to just being able to develop the data centers at the pace we want to. So you can do one of two things. You can put pressure on the utility side, or you can kind of think about your own sources of power outside of the utility grid, which we call the microgrid. And your, call it, suite of solutions can range from, energy storage, fuel cells, solar, and then your typical like reciprocal energy sources like a generator that uses diesel or natural gas, which are the conventional uses at the moment. And that's how people really set up their ability to have the core redundancy requirements that allow for us to maintain operations and uptime in the case of the utility faults, or there's a block there. So this goal, this call it roadmap of being able to develop our own grid that sustains itself without dependency on the utility is absolutely where a lot of attention is being placed. And then it's about, once you've gotten stability and even excess of that energy, because you're developing more efficient ways to do it. I mentioned some ways to do it. There's discussions about hydrogen, and even there's talks of nuclear in some circles. These are all focused around the idea of being able to be behind the meter, on the data center side of the conversation, and how can that energy be support a microgrid so you're not dependent solely on that utility distribution constraint. So the Endeavor, like I mentioned, is working on that on the engine side, on the interconnection side, back to the utility, because if we were able to be super optimized on our end, there's a way for us to even push energy back into the utility grid, and that's a whole other opportunity and business model. So that's the roadmap that creates our, call it, you could argue that's a business model that helps us differentiate Edged, because we are essentially, we have exclusivity with those technologies and with that access to that expertise. That's not going out to other data centers. I think that makes the Edge platform quite attractive. But it also is a business model that is, I think, really compelling for other types of customers, whether or not it's utilities or folks that want to use these technologies for other applications, so it's the government or something else. So the range of possibilities is quite significant, but the data center focus is where we'll scale up those technologies first, get them piloted, tested, and at a price point that works to scale up beyond into those other verticals.
Yeah, that's super interesting. It's probably a good note to end on. Actually, this again, you mentioned this recently. We spoke about this idea that one of the sort of prerequisites of being able to properly industrialize construction is a sort of consistent pipeline. It's a need for standardization. Data center clients, I think you were talking about, have the pipeline, they have the money, they have the long-term investment needs to keep iterating and going on this path. But I hadn't thought of it in those terms before. The idea that you might use data centers as a way of testing and developing other technologies that might have a life well beyond the data center market, but you use the desperate need for data centers and their need to industrialize and decarbonize to develop a load of other things that you might solve some other global problems whilst cracking data centers. That's amazing.
One of the biggest reasons why I like to think that I like my role and why I'm in this role is I've always lived in operations, but I've always been an innovator in my call it craft or career. And so I feel like the best way to make an impact and moving the needle and making, innovating, you kind of have to be on the execution side. And so what makes Edged really unique is that we have to be obviously very strategic about when and what projects to deploy a new technology, just like any other company goes through an engineering development process and ensures that new product introduction is correct and ready. Those gates all have to exist for us that maybe wouldn't for a more typical developer. But it is exciting because Edged has that mandate as a part of the Endeavor ecosystem to be a deployment partner of those Endeavor technologies. And I had a conversation internally about how the people who join our company are coming from some of the best companies with the greatest experience. I asked them a lot, like, what what gets you jazzed? Like we're at growth stage. It's exciting. We've got real work. We've got support. Like it's all happening. And oftentimes it's like, well, I'm excited about the overall vision. I'm excited about the sustainability piece. I'm excited about the new technologies that Endeavor has its hands in. They're not just waiting for what the market provides. We're upstream thinking about what needs to be developed to solve the goals and the challenges that we're all facing across the world. And that all goes back to, this nexus of demand for IT, given all of our technologies and the, going to 5G, and everything is, becoming more and more instant from our screens and our experiences personally and in our work world. So all of that is pushing on the needles of those particular business models that deliver those services, which influence their need for IT, which influences the data center space, which is all putting pressure on this energy question. It's one of, like, I forget the percentage you mentioned, but it's a high percentage that the data centers will have. There's a lot of other demands in that pie, but overall, it's a significant piece. And I think with AI, it's only continuing to increase.
Fantastic. Yeah, no, we love things on this podcast. The whole point of the podcast is sort of looking at this convergence and the kind of cross fertilization across industries and things. But yeah, you're living it. You're absolutely embodying it. So yeah, always exciting, always inspiring to talk to you. So thank you ever so much for joining us. We could talk for a lot longer, but yeah, I need to go and have a think about that. But thanks ever so much, Lincoln.
You bet. Thanks for having me.
So thanks everyone for listening, and please join us for the next episode of Built Environment Matters.
Thank you for listening to Built Environment Matters, a podcast brought to you by Bryden Wood. Listen and subscribe wherever you get your favourite podcast, and you can follow Bryden Wood on LinkedIn and Twitter.